We live on a beautiful water world, a pale blue dot just swarming with life. Our planet is chilling in a delicate balance, a perfect spot in the cosmos. But what if our closest neighbor, our so-called twin, was once just like us, before it turned into a complete nightmare? I'm talking about Venus. A world named for the goddess of love, but it's a place of absolute torture. NASA themselves called it a hot, hellish, and unforgiving place. For decades, we've basically ignored it because it's just that terrifying. But now we're preparing to go back. NASA is about to take an insane plunge into a world of corrosive acid clouds and crushing pressure, all on a one-way mission to find the ghost of an ancient ocean. This is the insane story of Da Vinci, a mission to dive straight into hell to answer one of the biggest questions ever. Was Earth's twin the first casualty in the search for life? To get why we're going back, you have to understand why we call Venus Earth's twin. On a cosmic scale, they're almost identical. Venus is about 95% of Earth's size and has 81% of its mass. It's a rocky planet, like ours, and it gets a lot of sunlight. Some hypotheses suggest that billions of years ago, Venus could have been a temperate world, with continents and huge life-giving oceans. It might have even been the first habitable world in our solar system. But somewhere in its past, something went horribly, horribly wrong. A runaway greenhouse effect took over, trapping heat and literally boiling its oceans away. Today, the surface of Venus is a pressure cooker. The temperature is over 900 degrees Fahrenheit, or 460 degrees Celsius, hot enough to melt lead. The atmospheric pressure is more than 90 times what we feel on Earth, which is like being crushed under the weight of water almost a kilometer deep in the ocean. And its sky is permanently filled with thick clouds of highly corrosive sulfuric acid that can attack many materials. Venus is a warning, written on a planetary scale. It's Earth's twin that took a seriously wrong turn. Figuring out how and why their paths split isn't just for bragging rights in science class. It's critical for understanding our own climate, the tipping points that can flip a paradise into a wasteland, and just how rare planets like ours really are. For the first time since the Soviet Vega missions in 1985, we're sending a probe to actually enter that atmosphere and get some real answers. Surviving Venus is one of the craziest engineering challenges ever. The last probes to brave its atmosphere were the Soviet Vega 1 and 2 in 1985. Before that, NASA's Pioneer Venus multiprobe was in 1978. The Soviet landers that made it to the surface transmitted data for up to 2 hours before the extreme conditions finally killed them. The Da Vinci mission, which stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry, and Imaging, is our modern-day champion, built to face this nightmare head-on. The mission has 2 main parts: a carrier spacecraft that will study the planet during 2 flybys, and a descent probe heading for that one-way trip. This probe is our hero. It's a sphere, about 3 feet wide, built with a titanium pressure vessel, a material chosen for its incredible strength-to-weight ratio and resistance to corrosion. It's basically a flying fortress, designed to protect the most advanced science lab we could stuff inside from the inferno outside. But before it can do its job, it has to survive the fall. It'll smash into the upper atmosphere at insane hypersonic speeds, protected by a heat shield. At an altitude of about 67 kilometers, that shield gets tossed, and a parachute deploys to slow it down. Then, in a wild move, it will cut the parachute away halfway down to fall even faster through the lower atmosphere. For 1 hour, this probe will fall through the depths of Venus, tasting, smelling, and seeing a world we've only dreamed of. Once that sphere starts dropping, a symphony of science goes wild. 5 main instruments will fire up, each designed to peel back another layer of Venus's biggest mysteries. The Venus Mass Spectrometer, or VMS, is the probe's nose. It's going to sniff the atmosphere the whole way down, inhaling gas and analyzing it with insane precision. Its main target? Noble gases like argon and neon. These gases are like chemical fossils. They don't react with anything, so their ratios hold the secrets to how Venus formed and where its water came from. Working right next to it is the Venus Tunable Laser Spectrometer, or VTLS. This thing literally fires lasers into the air to measure other chemicals and their isotopes, giving us even more clues about the planet's lost water. Meanwhile, the Venus Atmospheric Structure Investigation, or VASI, will act like the probe's nerve endings, measuring the brutal pressure, temperature, and winds every single meter it falls. This gives us a complete profile of the atmosphere from top to bottom. The Venus Descent Imager, or VEN-DI, will look through a special protected window at the bottom of the probe. As it drops below the clouds, it will start snapping the first-ever high-resolution descent images of a mysterious ancient mountain range called Alpha Regio. The launch is planned for the late 2020s, with the moment of truth, the plunge, happening in the early 2030s. The target is Alpha Regio, a rugged highland region that's about 1,500 kilometers across. Geologists think these could be the remnants of ancient continents. Are they just old volcanic rock, or could they be like Earth's granite continents? Da Vinci is going to find out. For about the first 30 minutes of its fall, the probe will get battered by winds while flying through those acid clouds. The probe will break through the cloud deck. For the first time since the Soviet landers of the 70s and 80s, we will see the landscape of Venus from inside its own atmosphere. The VEN-DI camera will start taking picture after picture, capturing the twisted, folded terrain of the tesserae below. These won't be blurry radar maps. They'll be actual near-infrared images, revealing the texture and composition of a landscape that might have once bordered an ocean. The probe will keep transmitting data all the way down. It's not designed to survive hitting the ground, but if it gets lucky, it might keep sending data for a few brief minutes before the heat and pressure destroy it. The data Da Vinci sends back in its final hour will completely rewrite the book on Venus. The measurements could finally tell us if Venus really had an ocean, how much water there was, and when it all disappeared. The images of Alpha Regio will give us our first real look at the building blocks of this lost world. And Da Vinci isn't going in alone. It's part of a new golden age of exploring Venus. NASA's Veritas mission, an orbiter planned for launch no earlier than 2031, will create insane high-resolution 3D maps of Venus's surface. It'll work with Da Vinci, giving global context to the probe's up-close and personal data. Joining them will be the European Space Agency's Envision orbiter, scheduled to launch around 2031, which will use radar to literally peek under the surface to study the planet's core and mantle. Together, this fleet of missions will give us the most complete view of Venus we've ever had, from its deep interior to its upper atmosphere, in a massive international push to finally understand our sister planet. So why do we do this? Why send our best tech on a suicide mission into a planetary furnace? We do it because Venus's story is our story. By understanding the chemical fingerprints of its lost oceans and the scars of its ancient continents, we learn about the fragile balance that makes life on our own planet possible. The mysteries of Venus, its runaway climate, its missing water, its violent past, are questions about survival. The secrets Da Vinci uncovers in its terrifying final hour could help us protect our own pale blue dot for generations to come. This plunge is a heroic sacrifice, a journey into a hellscape that might just help us save our own paradise. The answers are hiding just below the clouds.